Okay guys, so we have looked at compound inequalities that involve the word or. But now we want to look at compound inequalities that involve the word and. So when you have a compound inequality, a compound, probability that involves the word and, you will multiply. I would make a note of that in your, circle that in your notes. You're going to multiply the probabilities of each individual event. However, you must first decide whether the two events are independent or dependent events. So independent events are events where the outcome of one event does not affect the second event. And dependent events, the events in the outcome of the first event affects the outcome of the second event. It does affect. Okay? So when you're able to determine what's independent, what's dependent, then you'll know which formula you use. The good sign is this. The good thing is this. Both formulas are the same. Both of these are the same. The only difference is, so this is probability of A times probability of B, and this is probability of A times probability of B after A occurs. The only difference is this after A occurs. And you'll understand that when we start looking at some of those problems in just a moment. So anyway, these are your formulas. So let's look at a couple examples to make sure you know how to determine what's independent and what's a dependent situation. We have our friend Henry, and he spins the spinner twice. Are these two events dependent or independent? Think of a game that you play, or that you've played before, you've seen before, that has a spinner. What's a game that we play that has a spinner? Twister, okay? So, if you spin the spinner, it goes around, it lands on red, then you spin it again. Does the next result really depend upon the fact that it had landed on red? No, it doesn't, does it? So are they dependent? Is the second one dependent upon the first? No. They're independent. If Nathan picks a marble out of these four, picks a marble at random, puts it back, and then picks another marble at random, is that situation independent or dependent? Pick a marble, put it back, pick another marble. Does the second picking depend on the first picking? No, it doesn't depend. It does not depend, so it is, say it, independent. Bridget is making a beaded necklace and plans to use each bead colored once. Bridget selects a red bead, then reaches for another color. Okay, so let's suppose these marbles up here in this previous example are our beads. Now Bridget, she selects a red bead, and then so she puts that on her necklace. She does not put it back. There's no replacement here. Now she's going to go pick a different color. Is this an independent or a dependent situation? It is dependent, right? It's dependent. Any questions? So write that down. Make sure you jot these notes down. A steakhouse cooks its steaks rare, medium, or well. Cora tells the waiter how she wants her steak done, and then her companion tells the waiter his preference too. Now, does Cora's companion, does his preference in how the steak is cooked, does it depend on her preference? No, it doesn't. I mean, I like my steak medium rare, and I don't care what you like. You know what I'm saying? Like, I like my steak the way I like it. So, this is independent. Okay, here's some examples I think that you probably, well, we'll go ahead and do them. Emily picks a marble at random without putting the first marble back. That's important. She picks a second marble. You determine, is this independent or dependent? I'm going to call on someone. What do you think, Haley? What'd you say? Dependent. Okay, maybe. And what do you say, Sedona? Dependent. Okay, so you both agree, and I agree with you. Dependent. Now, next example, May and her sister are picking out dresses to wear from May's closet. So May picks out a dress, and then her sister picks next. Is this an independent or a dependent situation? What do you say? Alyssa? You say independent? JC, do you agree or disagree? So you disagree. Okay, I've got one vote for independent, one vote for dependent. What do you say, Zach? Dependent? So why would this be a dependent situation? Here's why. It's May's closet. She walks in, she picks out her dress, snaps her fingers and says, "I got my dress," and walks out. And her sister is like, "Well, I'm thankful to be able to wear one of your dresses, sister." So, she picks next. But when her sister picks, does she get the full range of options? What do you say, Alyssa? Does she get the full range of options? Why doesn't she get the full range of options? Because May's already picked out one of the dresses, right? She's already hitting the town. So this is a dependent situation. Great. Okay, now, this is where we start putting it into practice. So I want you to find the probability. And let's move this up a little bit. Okay. You have a number cube, also known as a dice. Okay? And or a die, is dice plural or is it? Die. Die. Okay, so you got a die. Okay? A single die. It's a number cube. It's a cube. Looks like this. It's got how many sides? 6 sides. And you roll it, and it's number 1 through 6, and so you're also going to flip a coin. The coin has a side with heads on it, another side with tails on it. So what's the probability of rolling a number greater than 2? So I'm going to write this down. The probability of rolling a number greater than 2. Copy that down just like I have it. Rolling a number greater than 2. X is greater than 2. And flipping heads. first question I have to ask you is this. Is the problem independent or dependent? Let me hear from Selena. Let's try Brandon. Did you say independent? It is independent because I can hold the die in this hand. I can hold the number cube in this hand, and the coin in the other hand. I can flip the coin, roll the die at the exact same time, and what we get on one does not affect what we get on the other, right? It doesn't make a difference. So this is independent. So if it's independent, what is the probability going to be equal to? What's going to be equal to the probability of rolling a number greater than 2? What do I do here? Add. What's the formula say that I showed you just a moment ago? Multiply. You multiply. Whenever you have and, you multiply. So we're going to multiply probability of rolling a number greater than 2 times the probability of flipping a coin and it landing on heads. Okay, so probability of rolling greater than 2. I need to know that number. I'm going to ask you for it. Let me call on Joanna. Not here? Okay, I'm sorry. There's 6 sides, so that's going to be out of 6. And there's 4 options. You can roll a 3, a 4, a 5, or a 6, right? So there's 4 good, successful options out of the 6 possible. And you're going to multiply that by the probability of flipping a coin and landing on heads. And what is that probability, Josh? It's 2? What'd you say? How many outcomes are there total? Okay, how many total outcomes for flipping a coin? 2. Okay, and how many chances are there to land on heads? 1. So you're going to multiply 4 6 times 1/2, and you do that in your calculator. You can do it in your head, whatever works for you. 4 times 1 for me is 4, and 6 times 2 is 12. So 4 twelfths, put it in my calculator, 4 divided by 12, enter. It gives me 0.33, repeating, right? Now if I hit math, enter on my graphing calculator, I get 1/3 in its reduced form.
Hey, wait. Do 4/6 times 1/2, right?
Mm-hmm. Yeah, you can do it that way. Okay, we good with this? Next. Pretend it's the 90s and CDs are cool. You don't even know about that because y'all weren't even born in the 90s. Were you? Raise your hand if you were born in the 90s. 99. Dang.
98.
Let's go.
All right, well, I remember it was 1992, Christmas, and I got my first portable CD player, and I was going to be the coolest kid in school. Trust me. See, back then, I wasn't bald. My ears were still big, but, you know, I made up for it in having a nice CD collection. So, My first CDs, there were about 5 or 6 of them. I can't remember them all, but the number one CD that I still listen to today, in fact, it's out in my Jeep right now. It's A Tribe Called Quest. Most of you wouldn't know who that is, but that particular group is kind of foundational to, well, not foundational, but somewhat foundational to hip hop. Okay, they're a big deal. They produced about 5 or 6 albums, and one of the members died just last year. Okay. Anyway, suppose you have 7 CDs in a box. 4 are rock, 1 is jazz, and 2 are country. You randomly choose a CD, play it, and put it back into the box. Now that's key. You put it back. You put it back. That makes a big difference. That changes this problem. Whether you put it back or you don't put it back. All right? You're going to put it back in the box, and tomorrow you will do the same thing. What is the probability that you choose a country CD both days? It's a probability that you will choose a country CD both
So it'd be basically asking like what's the probability of using the CD that day?
Okay, so what's the probability that you choose a country CD both days? Okay, country, then country CD. Now, so this is going to be the probability of selecting a country CD today times, because this is an AND problem, even though it says then, it's an AND problem. Selecting country tomorrow. What's the probability that you select a country CD both days? So, what's the probability, I'm going to ask you this, you answer, what's the probability of selecting a country CD today? What is that probability? Let me hear from Damien.
For what? For one day or both?
Just the first day.
2 out of 7.
There's 2 country CDs out of a total of 7. We're going to multiply that times. What's the probability of selecting a country CD tomorrow? Mason.
2 out of 7.
2 out of 7. Now that's 2 out of 7 because why? We put the CD back the first day, right? You grab that door. Okay, so 2 times 2 is 4. 7 times 7 is 49. Put that in your calculator and give me the decimal. What do you get? Let me hear from Justin. Justin?
0.05.
Where you at? Right there. What'd you say? 0.08. Does everybody agree with this? Sounds about right.
Wait, why is this one a decimal?
Well, all of them have been a decimal.
Oh, we changed those to fractions.
Okay, if you change that to a fraction, you'll get 4 over 49. But why don't you go ahead and do that? Hit math, enter, enter. What does it give you? So I'll just include that. Okay?